This is an introduction video to reactive programming using Spring Webflux. Now, in this particular video, we won't be talking about uh, anything related to reactive programming. Like we won't be diving into code or anything like that. We'll first try to understand why we needed reactive programming, why it was, invented, or why it was established, and nowadays why it is hot, why it is getting used in the applications, in several applications. To understand that, let's first understand how a typical JVM-based backend works. I'll try to make you understand through this particular diagram. So there will be a client and there will be a server. Okay, now this is our backend. Typically, what happens, the client sends a request to the server, and let me just get this font bigger. Okay, the client sends the request to the server, and the server sends the response to the client. Yeah, this we know. This is how it works. But uh, what we want to talk about is what happens over here in the server, uh, the normal execution model. So server, a JVM-based backend typically uses a Java-enabled server. Now, what is a Java-enabled server? Java-enabled server makes use of Java servlets to serve the request. Okay. Now, uh, each server has servlets. Okay, and we make use of them to serve the response. Now, what are Java servlet? Java servlet is nothing but a simple Java program uh, which has access to everything that's coming from a request, and it makes use of it to process that request, and it can produce an output out of that request. So that's how uh, Java servlet works, or what Java servlets are. So a JVM based backend makes use of the Java servlet to produce the response. So what happens here is the request comes, and then the server gets the request. The server assigns uh, the request, one request, to a single servlet. The servlet processes that request, whatever the processing that it needs to do, and it gives the response back to the server, and server then gives the response back to the client. So this is how the whole flow works. Okay, so that's enough information that we need to understand how a JVM based backend works. Uh, and if you want to learn more about how Java servlets internally work, or how you can use native Java servlets to serve the request, you want to play with that API, that can also be done, but we won't be talking about that in this video, being an introductory video. Okay, so now we know how a JVM based backend works. Uh, okay, why did we talk about this? We wanted to talk about this because the reactive programming model was introduced to mitigate some limitations that this particular model brought in. Now, what are those limitations? Uh, this particular model did not have does not have any limitations. This model is being used in the applications which are there today as well. But the limitation kicks in depending on which Java servlet version you are using. If we are using any version uh, which is equal to or below 3.0, Java servlet 3.0, then we got some limitation over here. Okay, so let's talk about that limitation. Now, what happens in this particular backend is one request, as we talk about, it is request per servlet model. Okay, and servlet makes use of a single thread uh, on the server to serve the request. Okay? This is how it happens. So if we think about it, right, if we think about it, it is like this implies there will be a thread per request. You know, one thread will be used to process a single request, and that's how this particular model works. Uh, okay, we got to know about that as well. okay, there is one thread per request model, then like uh, what's the problem with that as well? Okay, so basically a server has certain number of threads only. Now in this thread per request model, right? Uh, if a thread is serving a certain request which involves some blocking operation. Now, whenever that blocking operation might be the server might be like the request involves talking to the database, get some response from the database or talking to some file system. So these are some blocking operations, and thread which was serving that particular request has no active role in doing that. So that particular thread will remain idle unless that particular processing is over. That blocking operation is over. So uh, if there are several requests which are coming to the server, and the requests are more than the number of threads which are available on the server, and many of the requests which are coming in involve some kind of blocking operation which is going to take some long. So those many threads will remain idle unless that blocking operation is over. Those free threads which can pick up some other requests won't be able to pick them up. They'll just remain idle over there. Okay. And that's why the application performance will be impacted. The other thing is, so if I note it down, uh, let me zoom in a bit. So basically, application performance will be impacted. Then resources are wasted. These two major things are happening. We are not using the resources efficiently. Those are being wasted. Those threads are being wasted over there. So these are very major limitation that this particular model brings in. Okay, and that's where we moved on to the non-blocking based models, the reactive models. Now, a reactive model can again still use the same thing underneath. It uses the same thing underneath, but it uses the Java servlet version, which is 3.0 plus, which is greater than 3.0. Okay, and why using this solves the problem? Because this provides a support for non-blocking IO. What does that mean is there will no longer be one thread per request. The thread won't wait until that particular request is processed. The thread will have the availability to pick up some other requests when it is blocked. So many servers like JT, Tomcat, etc. are now using the Java Servlet version 3.0, and there is there is a non-servlet server which is Netty that I know of. It also uses, it also supports non-blocking IO. Now, the execution model of Netty is a bit different than that of your typical JT and Tomcat Java Servlet based models. It has a different execution model. Okay, and I'll just clear this canvas out. Okay, so we'll talk about Netty. Uh, how how it works. Uh, like how do we get rid of the one thread per request model? So let's specifically talk about Netty because Spring Webflux, when you use Spring Webflux, right, it natively uses the Netty server underneath. So what I mean by that is if you create a Spring application which is using Spring Webflux, and if you start that application, it will natively start a Netty server unless you configure some other server. And that's why let's talk about just a Netty server, okay? How it's the execution model, how it works. So Netty server uses the event loop model that's there in the Node.js landscape to, all this request processing. The thread execution model is based on the event loop. Now, how does that work? Uh, so basically, uh, there will be this event loop. Okay, this is our event loop, and now there is a thread. okay, there are certain threads. This is a sorry for that. Uh, okay, so basically, let me just draw straight lines. So there are several threads over here which are serving certain requests. Okay, now I'll just name those threads. Maybe this is thread 1, this is thread 2, this is thread 3. Now each thread is serving a certain request. Uh, and there are some pending requests also. So this is one of the pending requests. Let's mark it like this. Okay, so this is a pending request, and there are one, two, three. These threads are so there are only three threads. We'll just talk about a hypothetical scenario. These three threads are serving the request. Now, this particular request one comes across a blocking operation. So there is a blocking operation involved to process this particular request. Now, the thread will be, you know, it will be idle unless that blocking operation is over. That means this thread can pick up some other requests for processing. Now, what happens in this event loop based architecture is this is very high level, right? This is just a mental model that I have that I'm explaining to you. It involves a lot of nitty-gritties, but we'll just talk about high level what happens. Uh, so basically, that request uh, will be posted to your event loop, and this thread can go and start serving the request that was pending. Now, uh, as you can see here, right, we did not block the thread. As soon as the thread was blocked, we uh, posted that particular request, the blocking request to the event loop. We made the thread free, and the thread went and started serving the other request, right? Uh, okay, so what happens when the processing is complete? So whenever the blocking operation, sorry, not processing, the blocking operation is complete, the event loop will inform that thread or any thread on the server that this particular request is now available again for processing. You can take it up and serve it, uh, and that's how it works. So basically, on a like if we talk about if we summarize this particular thing, the thread is not blocked, the resources are not vested. And if we talk about performance, uh, so if there are several requests which are coming in, then using this event loop model, the performance that won't be impacted that much. If there are several blocking operations, those requests will be posted to the event loop, and the threads will be free. The threads will still be there to serve the request. So the two major things that we talked about application performance and vested resources. Both of them are taken care of in this particular model, and that's why nowadays, if you have application that is going to scale, we basically should rely on the reactive programming model. We should use Spring Webflux, or if you are using some other language, uh, you should use the libraries which are part of the project Reactor, right? So that's what I wanted to explain, like how reactive programming is different than normal uh, execution, uh, normal JVM backends which were there, and uh, how it has advantages over them, and why should we learn about it? Why should we uh, start using it? Uh, yeah, so that's pretty much of it for an introduction video. Now we'll be majorly talking about the project Reactor, uh, right? What all things it provides, and how to code with it, what all operators are there, uh, how to have that idea around uh, what kind of programming paradigm it is, and when you are writing code, how to think about it, reactively. So, uh, those things will be covered in the upcoming videos. Uh, yeah, and thanks for watching this video. Uh, we'll be covering certain operators of this project reactor in the upcoming videos. So stay tuned. Thank you.